Hello, everybody. This is Group 2 doing white box testing. I'm Jared Beagley.
I'm Braden Steiner.
I'm Trenton Hamilton.
And I'm Jared Mefford.
White box testing refers to test methods that rely on the internal structure of the software. So in other words, if you had a box, what the user sees and utilizes is the outside of the box, whereas white box tests would evaluate what is the inside of the box, or in other words, the code itself. And the adequacy of these test cases is assessed in terms of the level of coverage of the structure they reach, or in other words, how much of the inside of the box is tested.
Some synonyms of white box testing are glass box testing, clear box testing, open box testing, transparent box testing, structural testing, and logic-driven testing.
How to do white box testing. Examine the inner workings of the source code. There are many different ways to do this. Unfortunately, we do not have time to cover every different way to do this, but we will be talking about some of them afterwards. White box testing will help you discern any errors in the source code. What you do is look at the code and derive test cases. These test cases will be individually tailored to the problem at hand and will be different every time.
5 of these basic techniques to do white box testing include control flow, branch testing, base path testing, data flow, and loop testing. Control flow testing uses the derived test to ensure consistency of execution by multiple similar tests to ensure consistent results, versus using fewer, more complicated tests that do not ensure consistent results.
The objective of branch testing is to try and make sure that you account for every possible option that could come through the area that is being tested. That way, by so doing, you will be able to account for all of the different outcomes that are possible.
The purpose of basis path testing is to determine the logical complexity of your product, and then use that to create a basic set of execution paths that the users may utilize for your product.
In data flow testing, the control flow graph is annotated with the information about how the program variables are defined and used. This may include following variables through their various life cycles, and in-depth commenting of the code in order to describe them.
Loop testing exclusively focuses on loops to ensure that they are constructed correctly. This includes entering and exiting correctly, as well as executing the correct amount of iterations.
So to give you an example of when white box testing might be used, or an equivalent of white box testing, let's say that you've got the steering wheel of a car that's being manufactured. Now, generally as a driver of the car, you're going to want that steering wheel to work pretty well. And so they're going to go through a ton of different ways to test it and make sure that everything is all hooked up together and works fine. So if you weren't using white box testing, you might just put it together and then test it out a couple of times to make sure it works. And by doing so, you'd be hoping that all of the possible scenarios were taken into account. But like I said, this is something that's very important that it works right, and you don't want to be driving down the road, hit a bump, and all of a sudden your tires flip around backwards. So what the best way of doing this would be is to take the steering wheel, take all the mechanisms that are associated with it, and ensure by examining the inner workings of them that they are all hooked up correctly, that each and every one of them performs the function it's given properly. That way, you can account for every different possible income and input and outcome from using the steering wheel. Like, for example, if you are driving up to 120 miles an hour and turn it all the way, that might not be something that the normal testers, when they're just using it, would do. But you want to ensure that it handles itself in a proper manner in situations like that.
An example of code, we're going to use a for loop. So looking at this one, we are going to receive some user input, and we are going to print out the numbers from 0 all the way up to that user input, including that. So looking at this code, we are going to derive a couple of test cases that we could use to test it to make sure it's working properly. One of the things that we can look at, well, user input isn't necessarily defined. So what if it has a different data type? So what if we put in a float, a double, or a character data type in for the user input, what kind of effects will that have on this loop? What else would happen if the user puts in a negative number? Will this loop just go on continuously forever, or will it break out? That's what these test cases are for. And so we will test every single one of them and determine if this for loop will work correctly. So we are looking for, will it terminate on time? Will it start on time? And is it doing what we want it to in the first place?
Another example of white box tested is demonstrated in this data flow. For this example, we have an if statement. Our if statement is trying to determine whether or not we pass this class. We're passing in the variable grades. We want to know that if we pass in the correct grade, will we get to execute the function graduate? And if pass this class returns a false answer, we need to make sure we're taking a retake. Some things we need to check are we passing in the correct value? Is grades what we think it is? Another important step is it doing the correct thing? Is pass this class returning a Boolean statement so that our if statement can be executed? Is it also obtaining the right information? If pass this class gets passed in an A, does that return true? What about a B or a C? What about another letter that doesn't fall into this category? Another possibility is a number. Would it accept numbers? All these test situations need to be identified. In order to understand exactly what's going on, we need to be able to identify whether or not a true or false answer has been reached correctly.
So there are several upsides to white box testing. Some of these include the following. Since you're going through source code, you will know the location of bugs or failures. They are easily identified as you go line by line looking at the code through several iterations. As you do this, you will also be able to notice poor coding practices, as they will be very blatant red flags to good coding practices that you'll be able to notice. Well-written code intentions are also more evident as you go through line by line. Since we are going through several times looking at the source code, we are able to understand the full capabilities of this program, and we'll be able to receive 100% coverage of the program, as every line or every method is tested as needed.
Along with the upsides, there are also several downsides to using white box testing. For one thing, it's harder to account for every unexpected user manipulation. In other words, you have to account for every possible input, as well as every different way that the user could use the methods that are being called. Also, it's hard to follow variables through several complex areas of code. You must have also a full knowledge of the source code in order to be able to effectively use white box testing. And because you've often been involved in the coding itself, you don't have necessarily a fresh set of eyes to get on the code so that you can be able to identify errors that you didn't realize you had made before. Also, white box testing is extremely expensive as you try to test every single function with the different inputs.
A simple recommendation for using white box testing is when you have access to the code and you absolutely have the need for exhaustive testing. And here are our references.